Hi everyone, here is topic 6 and I want to start that. This is the first video, graphing exponential and logarithmic functions. So that's the lesson. So before I go to the lesson, I really like you to see what's the reason we need this lesson. Okay, let's see this function. So this is a function that if you give me t, I do 3 power t and then I multiply with 4 and I give result back to you. So that's the output. So the input is t and output is that result. Okay, so let's complete this table. So if t is 0, so what is the result? Okay, 4 multiple 3 power 0, which is 4 multiple 1. If t is 1, it's 4 multiple 3, which is 12. If t is 2, is 4 multiple 9, which is 36. If I do 3, so it's 108, 324, and 972. So you can see it starts from a very low value, so which is just 4, and it goes to almost 1000. Okay, so if I want to graph it, so of course I cannot show everything very well on y-axis because I have from a very low value and until 1000. Okay, so I have to divide the part that I have, which is here, between 1000 values, so it doesn't show me everything very wide. For the t or for the time, it doesn't matter. For the time, yes, it's just 0, 0, 1, 2, 3, 4, 5. So yes, I can show everything wide. Okay, so I show the answer here. I show the graph here, and then I ask you what is y-intercept. Okay, what is, for example, the value of y if I give you t equal that? What is value of, for example, t if I give you y equal that? And I want you to answer all of them using just a graph. Okay, so I tell you what is the y-intercept. So you go to your graph and you see y-intercept is almost 0. This is almost 0 because it's very small. It's just 4 and I have to show 1000 values on that. I have to show 1000 values here, so I cannot show 4 really clearly. Okay, so I don't see it. Using the graph, I don't see it. Yes, I know what is y-intercept because y-intercept is for t equals 0. So what is y, or what is it n here? Yes, what is n here? So what is n0? This is n0. So I can go to my table and I can find the answer. Yes, n0 is 4. Okay, from the table, but not from the graph. Okay, so then I tell you, using your graph, find the number of cells at half an hour. So you say, okay, half an hour is here, and number of cells. Okay, when I make a perpendicular line on, I see, oh, it's a C0. Okay, because the graph doesn't show you, the graph is not clear. Okay, so but I know if I substitute half, it must be 4 times 3 power half, which is 4 times radical 3, which is almost 6.9. Okay, so how about the next one? How about if you have 3.5 hours? Okay, you go to 3.5 hours, which is here, you make this here, and then you would say, okay, so it's maybe I change the color. Okay, so it's almost here. Oh, it's less than 200, but I'm not really sure what. Okay, so I would say, okay, so how about I do 4 times 3 power 3.5. Okay, so what is the answer? So it's 187. Yes, it is less than 200, but it's not clear on the table. Okay, so using your graph, find the time when you have 50 cells and find the time when you have 800 cells. Okay, so means here I give you y, here I give you, okay, here I give you t, and you are calculating nt for me. Here I give you nt and I want you to tell me t. Okay, so 50 cells, 800 cells, what is the time? Okay, so I go here. Okay, 50 cells is almost here. Okay, I change the color to this. 50 cells is almost here, so I continue. Okay, so it must be 2 point something, but I really don't know because I'm not really sure. Okay, so how about 800? 800 is here, so I make that and then this, and okay, so 4 something. Okay, so I say, okay, how do I calculate it? How do I calculate? So it is 50 equal 4 this 4 multiplied 3 power t, and this is 50 divided by 4 equal that, and this is logarithm 50 divided by 3 equal 3 logarithm this. Okay, so t comes there, and so t is logarithm 50 divided by 3 divided by logarithm 3 here. Okay, you can calculate the answer, and then the answer is so the answer is 2.3 hours. The answer is 2.3 hours. Okay, so how about for 800? How about for 800? I can do for 800 here. Okay, so 800 equal 4 this multiple that, so 800 divided by 4 equal that, which is 200 equal that, which is logarithm 200 equal t logarithm 3, because I want to release t from the power, so I do that. I do logarithm of both sides. This is from topic 4. Okay, so t is logarithm 200 divided by logarithm 3, which is the answer is okay, 4.8 hours. So 4.8 hours. So here 2.3 hours. Okay, so these are, yes, these are I can find using the equation, because I already have the equation. But how about if I don't have the equation? If I don't have the equation, I just have table of values, I just have some values, and then I ask you the question. Okay, so yes, you graph it, I know. I give you values, table of values, you graph it, but then I ask a question. This is not clear for me when I go to this graph, because the graph is from 0 to 1000, so everything is just very compact in this section, in just a small part. Okay, I have to show all the values here from 0 to 1000, so I have to divide my, if you remember Math 171 graphing, you divide values that you have, the maximum value minus minimum value, or sometimes just maximum value, divided by the amount of square that you have on the graphing paper. And then you say, okay, I have to go this by this, I have to go 100 by 100, I have to go 10 by 10. Here you cannot show everything clearly because it's from 0 to 1000, 4 to 1000. See, I start from 4 and then I reach to almost 1000. Okay, so values are so large. Okay, so here I have the equation. Thankfully I have the equation. I have the table of values, so I graph it, doesn't matter. Then I use the equation to answer all of these questions. Okay, so this is yes, this is for here. So yeah, this right now I have to answer this. So describe the curve of best fit that you draw. So what is the curve of best fit? So the curve is increasing so quickly, so I have to write the curve and n values which are range are increasing so quickly. Okay, so it starts from 4 and then it goes to, it starts from 4 and then jump to 12 and then jump to 36 and then jump to 100 and then jump to 300 and then 1000, almost 1000. Okay, so it's just goes so quickly here. Okay, so it's increasing very quickly. Okay, so here now, okay, so let me see. So just the OneNote is not really always cooperating and it's really bothering us. Okay, so here now it's saying, okay, it's saying, how about we don't show the graph on the linear paper, just the way that we did so far, just linear graph paper. How about if I don't do that? How about if I use Semilog paper? What is Semilog paper? Okay, I can show you Semilog paper. Semilog paper is this kind of papers. You have linear here, the same as before here, the same as before here, linear. This is exactly the same as before. So you have a graphing paper the same as before for for x-axis. For x-axis you can divide. For example, I have 7 items, I have 15 parts, I do 7 divided by 15. Okay, so I jump 3 by 3, I jump 2 by 2, like that. So the way that, exactly the same way that we did last semester. However, for y-axis, okay, and here y was problem, okay, so for y-axis I have, here I have logarithm. So instead of the value, the paper itself, this is nature of the paper. The paper itself is showing me logarithm. Okay, so it's showing me everything wide. So what do I mean here? See, the paper starts from 1, okay, and each section, each cycle that you can see, this is cycle number 1, this is cycle number 2, this is cycle number 3, it goes 10 by 10. So for example, the first cycle is 1 to 10. The second cycle is 10 to 100. The third cycle is 100 to 1000. The paper itself is doing for you. Okay, so I do 1, 2, 3, 4, 5, 6, 7, okay, 8, 9, 10. Then I do 10, 20, 30, okay, 40, 50, 60, 70, 80, 90, 100. Then I do 100, 200, 300, 400, okay, until I reach to 1000. So 10 by 10. Okay, so what do I have for log 1? What is log 1? Log 1 is 0, log 10 is 1, so log 100 is 2. So log 1000 is 3. Okay, so I am showing, for example, from 0 to 1, 1 to 2, 2 to 3, just I am showing it very wide because I use logarithm values. So the paper itself is doing it for you. Okay, you don't need to use logarithm values of y that you have. You use the same values. The paper is doing it. Semilog paper. So for x values or for t values, for the input values, no, it's the same as before. For output, for nt, for y values, for range, the paper is doing it, just is projecting everything to logarithm values. And each cycle is 10 by 10. So 1 to 10, 10 to 100, 100 to 1000. Or for example, 0.1 to 1, 0.01 to 0.1. Okay, so it's multiple of 10, right? Okay, so now I want to show what happened here if I use this Semilog paper. What happened? What happened for my thing? Okay, so let's see. I have nt equal for 3 power t. Yes? What happened if I do log of both sides? I told you, if I do log of both sides, if I do ln of both sides, if I multiple both sides, if I divide both sides, I didn't do anything wrong because I am doing to both sides. Okay, so logarithm n is logarithm for 3 power t. Oh, which is logarithm 4 plus logarithm 3 power t. Okay, based on logarithm rules. Okay, which is logarithm 4 plus 3 logarithm 3. Oh, sorry, t logarithm 3. Okay. Oh yes, I can see it looks like a line. Do you remember? It looks like a line. So I have logarithm n equal logarithm 4 plus t logarithm 3. So do you remember that? So it's like this is a slope, for example, looks like a slope. Do you remember? So it's mx, a slope. This is, for example, like x here, okay, but here we have t, doesn't matter, so this is just a variable. And here is like y-intercept. Do you remember this? And this is y. Oh, okay, so for y values I see logarithm. Also for a slope, because a slope is also different change on y over change on x. So logarithm for top, bottom, no. Oh, okay. So I don't need logarithm for this guy. No, this is just x. I just use logarithm for y. That's why I tell you use Semilog paper, because Semilog paper just uses logarithm for y values and not for x values. For x values it's the same as before. Okay, for the x values it's the same as before. Yeah, so it's talking about the distance. So the distance y equal 1 to 10, okay, and then I have 10 to 100, and then I have 100 to 1000. The distance is this, so is the same. It's just a cycle. Look at here. See, I have from 1 to 10, the same as 10 to 100, the same as 100 to 1000. Okay, because it is 10 power 0, 10 power 1, 10 power 2, 10 power 3. Okay, so I start from, for example, 1 to, so which is 1 to 10, and then 10 to 100, and then 100 to 1000. What is logarithm here? What is logarithm 10 power 0, which is just 1, 0. Logarithm 10, 1. Logarithm 100, 2. Logarithm 1000, 3. See, from here to here 1, from here to here 1, from here to here 1. That's why it's the same on the Semilog paper. Each cycle is the same, and it goes 10 by 10. Okay, so for the first one, 1, 2, 3, 4, 5, 6 until 10, and then 10, 20, jump 10 by 10, and then jump 100 by 100. Okay, and continue the same. Based on my need, I'm going to show you on examples that what you need. And another point, on y values, you do not start from 0 at all. On y values, you do not start from 0. Why? Because log 0 is not defined. So I start from 1. See, I start from 1. So you have to pay attention. For y values, make sure you do not start from 0. Oh, okay. So here, this is 0, but this is 1. Okay, so now I want to show you this. Okay, so I want to show you this. The question that we had. Okay, this was the question. Okay, I have the graph. I have the equation. Okay, when I have the equation, I can calculate my values. Okay, so it was 4. It was, I don't know what's wrong with OneNote. So 4, it was 12, it was 36, 108, let me remember. Yeah, 324, and I think 972. Am I right? So 972, 300, yes. Okay, yes. So I did the graph for you because I didn't want to waste time, but I'm going to here to just to do graph because OneNote doesn't really help me to do the job fast. Okay, so but I want to explain it here. See, here you have the equation. Okay, but in most cases you do not have the equation. So what you have to do is you receive this, you receive a table of values, and then you have to graph it, and then you have to find the equation. Oh, okay. So here I have the equation, but let's say I receive this and I have to graph it on Semilog paper. Why it is semilog? Because I see y values is jumping by logarithm, but x values, no, it's the same as before. Look at this, all the space are the same, they are equal, space are equal for x values. Oh, that's semilog. Okay, so now I graph it here. Okay, I have 5 values for x. For x I can do that. For x I can say, okay, I have a space, so I go 3 by 3. This is just for x. Remember, for y I cannot do whatever I want. No, I have to follow rule. Oh, okay. So I do 3 by 3. So I make, this is 0, this is 1, 2, 3, 4, 5 on x-axis. How about y? Okay, I look at my values. I have 4, so I need 1 to 10. I need 1 to 10. I have 12 and 36, so I need 10 to 100. Oh, I have 100, 300, 900, so I need 100 to 1000. Oh, I need 3 cycles. So I go 1 to 10 here, 10 to 100 here, 100 to 1000 here. Then I find my values. Okay, 0 and 4. Look at this, 0 and 4. Okay, 1, 2, 3, and this is 4, 0 and 4. 1 and 12. 1 is here and 12. Okay, so this is 20. This is 20 here. Oh, okay, so 12 will be a little bit upper than 10. Okay, then 2 and 36. This is here. Okay, 20, 30, 36 is almost in the middle between 30 and 40. Okay, 300 and 108. Okay, the first one is 100, the second one is 200. Make sure don't go in the middle. No, 108 is just very close to 100 because the next one is 200, not 110. Sometimes I see a student make mistake. They go to the middle because they say, oh, it is 105, for example, or 108. They go close to the next one. No, this is 100 and 200. So it is 3 and, yes, here. Okay, so, and this one here. Okay, 4, 325. So this is 100, 200, 325. Just between 300 and 400, just 324. Okay, so 24, yeah. 5 and 972 is almost 1000. So I go here, and these are all almost. Okay, or almost. Then I connect them, and the paper itself, the nature of the paper shows me a line. The paper itself. Remember, I do not use logarithm values of these. No, I use the same value. The paper itself is doing it for me, and then I see a line. If I don't see a line, means I made a mistake somewhere. Okay, so now let's go here. Okay, so I show you with another thing I wanted to show you, just to show you my way, and also show you with a graphing, like just a graphing app. Okay, so the next one is, how do the shapes of the function compare on linear graph paper versus semilog paper? So okay, on linear we have curve. On linear we have curve, but on semilog we have a line. Semilog shows us a line. Okay, and we saw the equation, we saw y. Okay, on semilog paper the function is like that. Okay, so let's do logarithm of that. Okay, so now I do one more time. So nt is 4 3 power t. Okay, so I want to, here I have the equation, so I do logarithm of both sides to show you what should I do to find the equation. If I don't have the equation, what should I do? If I don't have the equation, what is my option in order to find the equation? Oh, okay, so let's do logarithm of both sides. So logarithm of n t is logarithm 4 plus log, oh, okay, so I do it step by step. Yes, which is logarithm this plus this. Okay, yes, so it is like equal y-intercept plus x slope. So if I don't have the equation and I just have the data, I have a Semilog paper, I graph them. For x, I can say how do I jump? I can say, okay, I jump 3 by 3 or 2 by 2. For y, I can't. I have to follow rules. And I'm going to use the same values. I don't use logarithm. No, the paper itself is doing it for me. Then I want to find the equation. So means I need to find the slope and I need to find the y-intercept. What is y-intercept? Here, look at this. Y-intercept is the number like logarithm 4 and also that number. So that number is what? That number, when I go to the table, that number relates to t equals 0. This is the number. This is y-intercept, yes. So I make sure to use all of these. Oh, okay. So I need one of the values for t equals 0. This is my y-intercept. And I need to find the slope. How can I find the slope? So how do I find the slope? Here. What to do to find the slope? Okay, so here. Okay, again, let me write all the values. 4, 12, 36, 108, 324, and 972. I think I remember all of them. Yeah. Okay. So now I want to find the equation. To find this equation, look at here. I need to find the slope and I need to look at y-intercept. How do I find a slope? We know how do we find a slope? We find change on y over change on x. But change on y for Semilog paper is change on logarithm for top and change on x for bottom. Okay? So the first step is you have to pick 2 points. Okay? I recommend choose this point, the first and the last. Remember, y values are logarithm on the paper, but x values are the same as before. So I use this formula to find the slope. Okay, so how? Okay, logarithm, this is change on y. Logarithm 972 minus logarithm 4, because these are logarithm for and for y values, and for bottom, no, for bottom the same as before. Okay, so this is the answer. So 0.4771. Here maybe I tell you round to 3 significant digits. You can round and show me the answer, but make sure when you want to continue and use the number in the next calculation, you have to use the more digits number, so not rounded number with more digits. Oh, okay, so I found the slope. So okay, so how about y-intercept? Yes, for y-intercept I check n0, I check the value for 0. Oh, okay, so yes, I see 4 here. Look at this, I see 4. Okay, you see that? Okay, so now I can write the equation. Okay, I know y values are logarithm, so I write log n. I know the y-intercept is also log 4 plus t multiple 0.4771. Okay, so I want to find n. I don't want to see log n. So what do I do in order to say bye-bye to log? I use inverse function. What is inverse function of logarithm? 10 power. Okay, so I do 10 power logarithm n will be 10 power logarithm n plus t times this. Okay, so here is n equal 10 power logarithm n multiple 10 power t times this. How do I know? When I have addition in power based on exponential rules, this is multiplication. If you remember from Math 171. Do you remember? We had 10 power a times 10 power b. This is 10 power a plus b. Here I am going from this to this. From plus I go to the multiplication. Okay. Oh, okay. So then what is 10 power log 4? Oh, sorry, it has to be 4. Okay, so nt is 4. Yes, so maybe I do this from the beginning. I show it with all the variables I need, and then I do nt. Yeah. Okay. So here 4 multiple 4 multiple what? So do you remember this? So here I just do, okay, I just do that because I want to show you. Also I talk about this. Okay, 10 power ab is the same as 10 power a power b. Okay, so I am using this here. Okay, I'm doing this here, and then okay, so I have t multiple, so I can say 10 power 0.4771. okay, all of them power t. Yes, this is the green one. Okay, so maybe green is not really visible, so I do blue. Okay, this is that. Do you remember this from Math 171? If I have power on power, then I multiple them. Here I have multiple, so I go to power on power. Okay, so then what happened? Okay, nt is 4 multiple. What is 10 power that number? Okay, so 10 power 0.4771 is almost 3. It's 2.99, so I just round it. Okay, so it is 2.9998 power t. Okay, which is 4 times 3 power t. Oh, perfect. I found my equation. So let's say I didn't have my equation, I could find it. How do I find it? Look at this page. I find 2 points. I find logarithm of y's, change on logarithm, top, and divided by change on x, change on input, change on t. I find the slope. I find y-intercept. And then I did this way to find the equation. You do not need to do this all the time. You can use the formula. Look at the formula. This is y-intercept from the table. Yes? So check the table, because this is 4. 4 is the value for t equals 0. Do you remember? So this is that value. And how about 3? Oh, 3 is 10 power m. So means I need to find the slope, and then I put 10 power m, and that's done. I just have it. Okay? So the equation the equation is n0 from the table, which is for t0, that I saw it there, the first value, which was 4, multiple 10 power slope power t, for example. Or if I have nx power x, if I have m power m. How do I find a slope? A slope is logarithm of y's, y2 minus logarithm of y1 divided by x minus x, x2 minus x1. Okay? So, means if I just have the table, this is my value which I have to use for b here, and then I do two values, logarithm of 972 minus logarithm of 4 divided by 5 minus 0. This is my slope. Then I do 10 power slope, and that will be the value that I have to use for base of power t, and then I have the equation. So I stop here and I continue in the next video to do the example that you have the table, you have values on the table, you don't have the equation. I want you to graph it on Semilog paper, and I want you to find the equation. And I continue, I show you a page that I have all of them summarized in by one page. Thank you.